I hope my audio is good. Sana hindi ako nagsasounding nasa loob ng isang lata, ano? Parang ganun yung nangyari sa 191 last time. But anyway, good morning, everybody, and happy December. It's the second day of December, week number 13, and that means malamig na ang simoy ng hangin, pero grabe yung simoy ng December, nangangamoy deadline because essentially, your works are starting to pile up. Lahat ng mga instructors nyo naghahabol na, kailangan matapos yung outline kasi matatapos na nga yung SEM. But I hope I can help you somewhat with it. Pero, I would be more lenient, pero sana you let me know kung paano ko kayo matutulungan when scheduling the deadlines, because I think I'll give probably two more laboratory exercises. So maybe I should write that down here. So two lab exercises remaining, and then we have one problem set, and then one final project. So ito yung apat na, or actually apat na natitirang components for this course. So I think the second to the last lab exer will be due on Monday. Medyo kailangan kong susugan yung sinabi ko sa inyo last week. I'll mention something about that later. So this would be December 5th. Okay. And then we still have another problem set. Should we do it December 12th or maybe December 19th para dun sa mga nagwo-151 dyan, hindi sasabay dun sa pre-final exam ng 151, yung huli nating problem set. So will that be okay for the others? I mean, doon lang ako may access or may knowledge dun sa schedule ng 151, Pero for those non-151 takers, will December 19 be better than December 12? Dahil wala namang violent reaction, so I guess let's put that here. December 19 will be the second to the last problem set. Second to the last lab exer. And the last lab exer on December 19th. And then the second problem set will be technically due on December 21st. That's the last day of classes. Pero I will accept submissions. Sige, tatanggap ako ng submissions para sa problem set siguro hanggang December 28. Though bawal ko siyang ilagay on paper na December 28 because madidemanda na ako kasi last day of classes. That pala off the record ko to sinabi. Magkaka-ebidensya kayo kapag inireklamo niyo ako sa OVCAA, Pero the official deadline for the second problem set would be on December 21st, the last day of classes. But I'll keep the Canvas submission bins open until the 28th. Just to give you a little more time to do it, para naman, sige na nga, ako na yung magsasacrifice kahit ipanghuli nyo na yung 174. Alam ko namang hindi ako yung laging pinipili nyo na i-prioritize, no? #hugot. Pero anyway, yeah. So let's have the deadline for the second problem set to be on the 28th, but officially it's on the 21st. So if you don't want your Christmas vacation to be ruined, so better submit it before the 21st. The format will be still the same. 5 essay questions. Again, do not give me an essay or do not lecture me. Do not give me back kung ano yung diniscuss ko sa inyo. Alam ko na yon. So, mas gusto ko marinig yung insights nyo mula dun sa problem, dun sa essay questions. So I want you to put it on your own words as succinctly as possible. 3 sentences will be enough. You don't need to put an entire paragraph. Pag nag-check ako ng essay, meron lang hinahanap na catchphrases, kaya mabilis ako mag-check ng essay. Meron lang mga words na hinahanap or specific thoughts na hinahanap. So okay na yun. Huwag kayong magnobela sa essay, And then there would be a little bit of a theoretical part. Siguro yung theoretical part, yung hindi natin na-discuss, probably finding the optimal step size in numerical differentiation, because I remember we didn't have any exercise on that. So I'll give you a formula, and then you'll have to find the optimal step size and implement that numerical differentiation formula with the optimal step size, right? And then the third one would be more of an application problem. So siguro yun yung lalagyan ko ng numerical integration problem that is embedded with real life data. because I want to make the last two laboratory exercises easier for you guys. So ano lang, magbibigay lang ako ng specific function, tapos ano lang siya, surface learning. I just want you to implement some numerical integration formulas or siguro mag-derive ng isang mabilis na numerical integration formula. But essentially, I'll just give you a function, little f, and then you do the magic of the numerical integration formulas. Nothing fancy, because I'll reserve the fancy one dun na lang sa problem set. Kasi nga, binigyan ko naman kayo ng isang additional week na palugit para sa problem set. So, you can think about it a little bit. Ano? Hindi katulad ng laboratory exercises na hard yung deadline. And then the final project, so start thinking about it. I'll hopefully we'll have time later to flash some sample projects. So you can work in groups of at most 4 people, but I won't force you to be in a group that you don't want to be in, or kung ayaw nyo nang magkaroon ng maraming ka-groups. So kayo na yung bahala mag-group sa inyong mga sarili. Pero probably I'll open up a Google form later or over the weekend para sagutan nyo kung naghahanap kayo ng ka-group. I know some of you might not have contact with other members of the class, but if you want to work in a group, which I guess is advisable para ma-distribute yung trabaho, ano. But if you're like me na introvert, tapos ayaw ko na may ka-group kasi gusto ko on my own pace ako nag-work, ano. So you can work alone, you know. But if you want to have a group mate, to interact with your peers, I guess that would be better para rin distributed yung trabaho. So magbibigay ako ng isang Google form para ilagay nyo doon if you're looking for a group, and then kung ilan yung ideal members na hinahanap nyo. So para ma-mix and match ko kayo, I'll try my best to optimize the grouping with respect to your request, with respect to the number of groupmates. Tapos, yeah, i-announce ko siya by the end of next week. All right, so watch out for that Google form. And then, yeah, that's the final project, and this would be due on January 11, the last day of the final exam. Tapos I'll read through your final projects within 5 days para mapasa namin yung final grade nyo within the deadline. So I think that's our calendar for the rest of the semester. So any questions, any appeals, any reclamos, any violent reaction? By the way, part of the final project, probably 1 point out of, say, 1 point out of 10 in the 1 point out of 10 ba? Siguro 0.5 point out of 10 dun sa final project will be, I need you to evaluate us through SAIS, the official student evaluation of teaching effectiveness. So participate in the process because it's a big help on how on our improvement of our teaching. So sagutan niyo yung SET sa SAIS, that's the official one. And then I'll give you another evaluation material which is more detailed, which is internal. That's just for me to look at para ma-improve ko yung susunod na iteration ng Math 174 at para ma-improve ko rin yung sarili ko. So part of the final project, 1 point for the final project will be from you answering both instruments, right? The SET in SAIS and the internal assessment form that I will give to you. So just make sure to answer them. Hindi ko na kayo hihinga ng proof na nag-submit kayo, ano, pero just be honest. Tatanungin ko lang kayo sa Canvas, did you answer the SET on SAIS and did you answer the internal assessment? You'll just put yes if you did it, and you'll get automatically the 0.5 points for the final project and for the and the other one also. Pero yon, pero sagutan niyo siya ha? Kasi malaking bagay para sa akin yung reflection on how I performed within the semester. Okay, with all of that out of the line, nagmamadali ako, no? Kasi nga, patapos na yung SEM. So, let's go to module number 9. So, module number 9 is, we'll introduce you to a brand new set of quadrature rules. Last time, pinag-aralan natin yung Newton-Cotes quadrature rules, which are basically quadrature rules. When we say quadrature rules, they are just estimates for the integral of a function. And this is in the form of a linear combination of function values. So you have some weights times some function values. Then you sum it up Doesn't matter if you start at 0 or 1. Siguro, medyo inconsistent pala ako sa pagkakasulat ko ng modules. This time in module number 9, I'm starting my summation from 1 to n para mas madaling magbilang. But I hope you're now familiar with shifting with the indices of the summation. All right. Now, essentially, ito yung mga quadrature rules. Ang natutunan natin sa Newton-Cotes quadrature rule module number 8, yung mga weights pala, pwede siyang yung integral ng Lagrange basis polynomial. Because the Newton-Cotes quadrature rules is simply replacing the function little f by the interpolating polynomial p. Tapos i-integrate niya si polynomial p instead of little f. And that is easier than the original function f because the integral of a polynomial is indeed, again, a polynomial. And computers are very adept in computing polynomials or computing with polynomials. So computers can differentiate, can integrate, and can do function evaluations for large polynomials. So that will not be a problem. So kaya napakagamit na gamit ng Newton-Cotes quadrature rules. Another advantage of the Newton-Cotes quadrature rules ay ang dali ng theoretical derivation niya. And so along with the theoretical derivation, we have an idea how big the error is. We have an error estimate. You just need to integrate the error term that came from from interpolation theory. What's the error bound from interpolation theory? Integrate mo lang yun yung magiging estimate mo para sa error nung integral of the Newton-Cotes quadrature rules, right? And then, aside from the theoretical relevance or the ease of the theoretical derivation, may isa pang advantage ang Newton-Cotes. Kasi dun sa Newton-Cotes, kaya mo siyang i-implement kahit ano pa yung mga exabytes na may access ka. Although we look at the closed and the open Newton-Cotes quadrature rules that have equally spaced abscissas, hindi kailangan na equally spaced yung mga abscissas. Kasi yung mga formulas na derive natin, equally spaced yung inassume niya. Pero again, at the back of our minds, yung Newton-Cotes quadrature rules is nothing more than integrating the Lagrange interpolating polynomial. So, hindi kailangan equally spaced yung mga ginagamit mong abscissas sa Newton-Cotes quadrature rule. Wala ka nga lang formula na magagamit right off the bat, right, or right off the shelf. So, kailangan mo kung ang given sa yung exabytes ay hindi equally spaced. Halimbawa, nag-collect ka ng data, tapos meron kang daily data supposedly, pero na-miss mo yung ilang mga araw. So, naging irregular yung spacing ng iyong data. So, pwede ka pa rin mag-Newton-Cotes quadrature rules. Kasi ang gagawin mo lang ngayon, kukunin mo yung yung interpolating polynomial na daraan dun sa yung mga data points na kinolect mo, regardless of how the abscissas look like. Ipa-plugin nyo siya dun sa program nyo way back, kailan ba tayo nagsimula? September? So tapos ipapa-integrate mo kay MATLAB kung ano yung interpolating polynomial na nakuha mo based of your data. And then you'll get your numerical integrations. So you really don't need the function little f. You can just have a discrete set of points and then you'll have an approximate for its integral. All right? So yun, yung mga advantages ng Newton-Cotes quadrature rules. At least yun yung mga pumasok sa utak ko ngayon. You can search for other applications because probably I'll ask you in the problem set what are the advantages of the Newton-Cotes quadrature rules, and I would love to see some other advantages that I haven't thought of before. So if you can do your research now and then take note of it, kasi malamang itatanong ko talaga yan. So I will be extra happy to see na meron kayong ibang sinulat. So para may matutunan ako habang nag-check ng inyong mga problem sets, right? Now, for this module, we are introducing another class of numerical integration quadrature formulas. In particular, we're looking at the Gauss, Legendre, the Gauss-Legendre quadrature rules. So, itong Gauss-Legendre quadrature rules, ang kanyang focus is on minimizing the error. Or in other words, it's minimizing the error in terms of catering to bigger class of functions. Kasi titingnan niya, gusto niyang i-integrate or paano mo may integrate ang mas maraming polynomials exactly. Or deriving the formula, the quadrature formula that will integrate as many polynomials as possible. So meaning hindi to data-based. katulad ng Newton codes. Kasi yung Newton codes, ang focus niya ay makakuha ng quadrature formula na magagamit mo kahit ano pang klase ng data yung may available sa'yo. Etong Gauss-Legendre quadrature rules, ang focus niya ay ano yung quadrature formula that will give me the greatest degree of precision. Sino yung formula na makakapag-integrate eksakto ng mas maraming polynomials? So that's essentially what we'll try to do today. Pero ang sister rito, dahil ang focus niya ay yung error, it's more of maximizing the precision of the formula, it will not work on just any abscissa. So kasi ang gagawin natin ngayon, pipiliin natin yung mga abscissas at yung mga weights dun sa quadrature formula. So these guys, the exabytes will not be arbitrary anymore, but they will be chosen purposively along with the weights associated with them so that ma-maximize natin yung degree of precision ng quadrature formula, right? So yun yung disadvantage ng Gauss-Legendre. So yung Gauss-Legendre quadrature rules, hindi siya nag-a-apply sa lahat ng functions or sa lahat ng possible data because the exabytes are chosen. They are prescribed. So ibig sabihin, magagamit lang natin itong Gauss-Legendre formulas kapag ka may access tayo dun sa function little f. Pag alam niyo yung function little f, then you can evaluate function values for any axis within the domain of that function little f, then pwede mong gamitin yung Gauss-Legendre. Pero kapag ka data-based ka, halimbawa limited lang yung data mo na binigay at nagkataon yung mga data na may access ka, yung mga exabytes nila ay hindi nag-match dun sa exabytes na pinescribe ng Gauss-Legendre, hindi natin magagamit yung Gauss-Legendre. So you're better off using Newton codes quadratures or Monte Carlo simulations, which we will talk about later in the semester. So dun sa pag-estimate or pag-approximate ng integral. All right? So that's why I need, this is a little bit shorter module than the usual modules that we have. Kaya feeling ko matatapos natin to ngayon. Tapos, that's why you'll have a laboratory exercise on the 5th of December. Although the content will not just be module 9, pero may kasama pang topics from module 8. But I'll make it simple na ano lang, gusto ko lang matry nyo hands-on paano nag-apply ng quadrature formulas. Probably I'll give you a function little f, and then I'll ask you to implement one Newton codes quadrature formula, or probably one or two of them, plus one Gauss-Legendre formula, and then analyze which is better, compare the estimates that you got, and so on. So it's going to be straightforward kasi kakaunti naman yung time nyo to study for the next laboratory exercise, okay? So here are our objectives: derive some Gaussian quadrature rules, and then use these quadrature rules to solve scientific problems. This second objective will be met when you do the problem set. Hindi na siya sa laboratory exercise muna, ano? So yeah, let's get it on. Okay, una, sabi ko kanina, yung Gauss-Legendre, pinipili natin yung mga weights at saka mga abscissas to maximize the degree of precision. Now, exactly what is the degree of precision? Well, definition 9.1 teaches us na yung degree of precision ng isang quadrature rule ay yung pinakamaliit na value ni m, okay? Ito, lagi ako nalilito rito sa pagdidiscuss ng 9.1. Essentially, repeat. The degree of precision ay yung number m such that, alright, na i-integrate nung quadrature rule nyo exactly lahat ng polynomials of degree m or less, pero magkakamali na siya sa isang polynomial of degree m plus 1. Right? So di ba meron kang quadrature formula, I sub n of p. Siya yung pinapang-approximate mo dun sa mga integral. So tingnan mo ngayon, nai-integrate ba nung aking na-evaluate ba nung aking quadrature rules ang integral ng isang linear ng isang polynomial of degree 0 exactly? Pag nabibigay niya yung eksaktong integral ng mga polynomial of degree 0, then you're good. Punta ka sa linear. Binibigay ba nito sa akin eksakto lahat, binibigay ba nito sa akin eksakto ang integral ng mga polynomials of degree 1? Dapat lahat sila na-integrate. or nabibigay ng aking quadrature rule ang eksaktong value ng integral ng polynomials of degree 1, and so on. Hahanapin mo yung pinakamaliit na degree, call it n plus 1, okay, ng isang polynomial na magkakamali na yung inyong integration formula sa paghahanap ng integral ng isang polynomial of degree n plus 1. Titingnan nyo kailan siya unang magkakamali. Take note of that degree, tapos tawagin mo siyang n plus 1, titigil ka doon. So, ibig sabihin, ang degree of precision ay yung pinakamaliit na integer m such that magkakamali lamang yung integration formula kay m plus 1 sa isang polynomial of degree m plus 1. Or alternatively, mas gusto ko yung alternative way. Papalitan ko na next semester yung definition ko, definition 9.1. Where is that? I think I wrote that there. The degree of precision of a quadrature formula is the greatest positive integer n for which the formula give exact value for the definite integral of all polynomial of degree at most n. So ito yung pinakamalaking degree m such that nai-integrate o nabibigay nung quadrature formula sa atin yung eksaktong integral ng lahat ng polynomials of degree m or less. Pero magkakamali na siya sa pagbibigay ng value doon sa integral ng isang polynomial of degree m plus 1. Alright? Is that clear? Parang simple lang yung concept pero pinaikot-ikot ko kayo, no? But hopefully you get the idea. Alright? For instance, let's have a quick example. Let's look at the degree of precision of the trapezoidal rule. Now, we need to know sino mga polynomials ang na-integrate or yung nabibigay ni trapezoidal rule yung value ng integral exactly. All right? And to know this, we can look at the theoretical error associated with the trapezoidal rule. So in the trapezoidal rule, ito yung kanyang error term, right? Ito yung resulta pag in-integrate nyo yung error term dun sa interpolation na nagamit sa trapezoidal rule. So ito yung theoretical error sa trapezoidal rule. Tapos hanapin mo, kailan ito mag-zero? Kasi gusto nating mag-match yung trapezoidal rule o yung resulta ng trapezoidal rule dun sa eksaktong integral na mga polynomial. Alright? So, question is, what are the polynomials little f such that this error term will vanish or will be zero? Kailan mag-zero to? Kaninong mga polynomials? Well, we don't have too much control about omega because omega is a polynomial of large degree and medyo mahirap i-analyze yan. But we can just look at f double prime of c. Alright? Si f double prime of c, hanapin natin kailan to mag-zero. Sino yung mga polynomial little f na mag-zero yung f double prime of c? So basically, that's asking the question, kailan nag-zero yung second derivative? All right. We know that the second derivative of a constant is 0. The second derivative of a linear function is also 0. All right. So ibig sabihin, sure na tayo na kapag meron kang constant function o meron kang linear function, pag in-apply natin yung trapezoidal rule sa kanila, eksakto yung value ng integral na makukuha natin. Because again, the error term will be equal to 0 because the second derivative of those polynomials will exactly be 0. Okay? However, madaling makahanap ng quadratic polynomial na meron ng error yung trapezoidal rule. Actually, graphically, madali nga siyang makita. Doon na lang sa y equals x squared. So pag gusto mong makuha yung integral ng y equals x squared, kukunin mo lang yung area ng region na to. Right? The area under the curve. Pero kapag gumamit ka ng trapezoidal rule, i-connect mo yung endpoints ng nitong interval na to. So if you use the trapezoidal rule, kukunin mo yung line passing through the two endpoints. Yung mangyari, ito yung estimate mo sa integral, which is not equal to the integral of x squared. Essentially, ang daling mag-cook up ng isang quadratic polynomial na hindi na eksakto yung value na ibibigay ng trapezoidal rule with respect to the integral. So that means, and actually, that's the constructive way of answering the problem. And another way is just saying, sir, meron kasing mga quadratic polynomial na yung second derivative ay hindi equal kay 0. So we know that the trapezoidal rule will fail to give the exact value of the integral for some quadratic polynomials. So eksakto yung integral na binibigay na yung value na binibigay ng trapezoidal rule kapag constant at saka linear, pero magkakamali na siya for some quadratic functions. So therefore, ang degree of precision ng trapezoidal rule ay 1. Kasi lahat ng polynomials of degree 1 or less ay nabibigay niya yung integral ng eksakto, pero nagkakamali na siya sa isang polynomial of degree 2. Okay? Is that good? Hindi kayo nag-react? Or delayed yung ano ko? Okay, thank you. Now, it might seem to be a daunting task. Parang sir, ang hirap mag-isip ng or hanapin yung degree of precision because for one, if you will go by the definition, we'll need to check kung eksakto ba yung nabibigay niya para sa lahat ng polynomials of a certain degree and smaller. All right? So sir, kailangan ko ba itong i-check sa lahat ng mga polynomials, lahat ng mga posibleng polynomials? Well, if you will just naively look at the definition, then you might think kailangan. Pero if you will use your knowledge about the properties of integrals, that will reveal na hindi mo siya kailangang i-check sa lahat ng mga polynomials. Kasi halimbawa, if we have a polynomial p of degree n, okay, consider natin yan. So the a sub i's here are constants, all right? So tingnan natin yung integral ng polynomial na to. Gagamitin ko yung linearity property ng integral operator, meaning the integral of a sum is the sum of the integrals, and the integral of a scalar times a function is the scalar times the integral of the function. All right? So, or in other words, ito yung term-by-term integration na ginagawa nyo before. So, integral ng polynomial ay magiging sum ng integrals ng mga monomials. Tapos, pwede mong ilabas yung mga constants. All right? No integrals, so you'll end up with this. So ngayon pala, makikita natin dito na, alright, hindi pala nagmamatter kung hindi pala kailangan na i-check ko kung eksakto yung integral na binibigay sa lahat ng polynomials. Kailangan ko na lang i-check, sakto ba yung integral na binibigay yung value na binibigay ng quadrature formula para sa integral ni dx. Kasi kung eksakto yung binibigay na value ng quadrature rule para sa integral ni dx, i-multiply ko lang siya ng constant na nandun sa given function, di eksakto na yung makukuha kong value of this guy. Tapos ganun din for all. Check ko lang, tama pa rin ba yung integral ni x or eksakto ba yung binibigay niya sa aking integral ni x? Tapos mamumultiply lang siya nung given a sub 1 dun sa polynomial, tapos linearity of the integral, eksakto yung makukuha mong integral for that term. And so on. So essentially, checking for the degree of precision now boils down to checking whether our integration formula will give us the exact values of the integral of 1, x, x squared, x cubed, until x to the power n. Hindi mo na siya kailangang i-check sa lahat ng mga polynomials. Kailangan mo lang siyang i-check para dun sa 1, kay x squared, kay x cubed, at kay x to the n. Kasi kung eksakto, yung value na binibigay ng integration formula para sa integrals ni 1, ni x squared, ni x cubed, hanggang x to the n, sure ka na eksakto yung makukuha mong value para sa integral ng kahit anong polynomial of degree n or less. Right? Ito yung isang magandang implications ng mga natutunan nyo mula sa linear algebra. Do you remember, yung mga nag-120 na dyan, do you remember the concept of basis para sa isang vector space? Or ayaw nyo ng pag-usapan? Sir, wag na nating haluan ng 120 itong 174, ano? Pero the idea here is 1x, x squared, x cubed, x to the fourth, and so on, hanggang x to the n, it forms a basis para sa lahat ng polynomials of degree n or less. Sa linear algebra, pag meron kang linear operator, hindi mo kailangang pag-aralan kung paano nag-act yung linear operator sa lahat ng elements ng vector space. pag alam mo na kung paano nag-work yung isang linear operator sa basis nung vector space mo, then you will know everything about the vector space. Parang ang galing niya. Yung vector space, pwedeng infinitely many yung laman niya. Pero yung dimension niya ay finite. So instead na pag-aralan mo paano nag-work yung isang linear operator sa buong vector space, kailangan mo lang palang pag-aralan paano siya nag-work doon sa mga basis elements, which is finite. Right? So ganun din dito sa polynomials. There would be infinitely many polynomials of degree n or less. And we want to check if our integration formula gives the exact value for their integrals. That will be an infinitely many long process. But since it's a linear operator, and we know a basis for the set of polynomials of degree n or less, all we need to check is whether the formula works for the basis elements. And if it does, then we can conclude that the formula will work exactly for the entire vector space. In this case, our space of polynomials of degree n or less. All right? So yun pala, para ma-ensure yung degree of precision, kailangan lang nating i-sure na yung ating integration formula ay eksakto para sa mga polynomials 1, x squared until x to the power n para masabi na siya ay of degree of precision n. Okay? Now, how do we enforce this? Well, again, ang gagawin natin ngayon ay first you'll start with the number of points that you want to use in your formula. So you'll need to decide ilang points yung afford kong gamitin dun sa aking computations. Call that little n. So if you want to have n points dun sa quadrature formula, then yun yung isa-set natin. So essentially, your goal is to have this formula. Yan yung goal mo na magkaroon. Kasi nag-decide ka na kung ano yung value ni n beforehand. Ilang data yung pwede mong gamitin, what's your computational budget, kasi ito yung number of points. Ayan yung magdedetermine gaano kalaki yung formula or gaano kahaba yung formula. So once you have decided to on the number of points that you will use, then that will give you 2n degrees of freedom. Ibig sabihin 2n yung magiging unknowns mo rito. So kasi kailangan mong hanapin sino yung mga weights at sino yung mga exabytes. So kasi may n points kang gagamitin, so magkakaroon ka ng 2n unknowns. You need to choose what are the weights. So meron kang n na terms, so meron ka ring n na weights. Tapos sino yung n na abscissa, sino yung mga n na function values. Alright? So meron kang 2n degrees of freedom na hanapin. Well, that 2n degrees of freedom will be able to give us at most 2n minus 1 precision. It will be clearer later kung bakit yung 2n na degrees of freedom pwede siyang magbigay sa atin ng at most 2n minus 1 na degree of precision. So, or you can work it backwards, ano? So kung gusto mong meron kang degree of precision, say, pero odd numbers lang to mag-work. If you want to have a degree of precision 9, all right? So equate this to 9, you can solve for n, so that will give us n equals 5, all right? So ibig sabihin meron kang 5 points, meron kang 10 degrees of freedom, right? So essentially that's the dynamics here. So n is the number of terms in your quadrature rule that will give rise to 2n degrees of freedom. You'll have n unknown weights, n unknown abscissas, and those degrees of freedom will give us a degree of precision at most 2n minus 1. Okay? So ngayon, kailangan kong i-enforce ngayon na makuha ko yung maximum na 2n minus 1 degree of precision. So ibig sabihin, para ma-attain ko yung 2n minus 1 na degree of precision, kailangan itong quadrature formula na to ay ibigay sa akin eksakto yung integral ni f of x from a to b, where f is a polynomial of degree at most 2n minus 1. Right? Para maging degree of precision niya. Dapat itong formula na to ay totoo, or itong equation na to ay totoo sa lahat ng function f na polynomial na ang degree ay 2n minus 1 or mas mababa. Okay? Is the process clear, or is our goal clear? All right? Gusto kasi makuha yung maximum degree of precision. And the maximum degree of precision, if you're using n points, is 2n minus 1. Kailangan ko itong i-impose. So di ba mahirap mag-ensure ng degree of precision kasi nga kailangang i-check natin to sa lahat ng polynomial of degree 2n minus 1 or less? Well, that's true. Pero meron na tayong na-note kanina. Doon ko na lang siya gagawin sa basis ng set of polynomials of degree at most 2n minus 1. So kailangan i-ensure ko na totoo tong equation na to dun sa basis elements. Sino yung mga basis elements? Si 1, si x squared, hanggang makarating ka kay x to the 2n minus 1. So dapat totoo itong equation na to kapag ka si f pinalitan ko ng 1, kapag ka si f pinalitan ko ng x, kapag ka si f pinalitan ko ng x squared, kapag ka si f pinalitan ko hanggang ng x to the 2n minus 1. So how many equations will I have from there? I will have exactly how many? Exactly 2n equations, right? Kasi papalitan ko si f ng 1, that's one equation. Papalitan ko si f by x, that's two equations. Papalitan ko si x ng si f ng x squared, that's my third equation. Pag pinalitan ko siya ng x to the power 2n minus 1, I have completed 2n equations. And that's a perfect match. We will get 2n equations, right? Tapos ilan yung degrees of freedom natin? Meron tayong 2n degrees of freedom. So essentially deriving a Gauss-Legendre formula tantamounts to solving a 2n by 2n equation. A system of 2n nonlinear equations in 2n unknowns. Unfortunately, yun nga, nonlinear yung equation, so hindi malamang gagana yung mga methods na natutunan niyo sa high school na Gaussian elimination, substitution, or Cramer's rule. Kasi nga, nonlinear siya. And unfortunately, yung pagsasolve ng nonlinear equations numerically ay nasa Math 175 pa. Alright? So ngayon, simple lang. Actually, bibigay ko sa inyo yung formula eh. Hindi ko na ipapakompute yung mga abscissas. But essentially, sa 175 next semester, baka ipagamit ko yung methods natin pagsasolve ng nonlinear systems para makuha yung weights at saka yung abscissas para dito sa Gaussian Legendre. So I'll be calling this back pag nag-175 tayo. But essentially, that's the plan. Buuin yung 2n by 2n na system of equations, and from there, we're gonna solve for the w sabays. Okay? So I hope the general picture is clear. And to make it clearer, kung medyo may problema pa, tumingin tayo ng specific examples. Right? So halimbawa, i-derive ko yung Gauss-Legendre o yung Gaussian quadrature formula using 1 point, right? So I'll be deriving the case when n is equal to 1. So kapag kasi n ay equal kay 1, so ibig sabihin isang term lang yung nandun sa quadrature rule ko. So essentially, our quadrature rule will look like this. Dahil ang n natin ay 1, so meron tayong 2 times 1 na degrees of freedom. Kailangan ko yung weight W1 at saka yung abscissa X sub 1. How will I choose W sub 1 and X sub 1? I will choose this so that I will get the maximum degree of precision. What's the maximum degree of precision? It's 2n minus 1. So that's gonna be 1. So 1 lang yung degree of precision. So ibig sabihin, etong quadrature formula na to, etong 1-point quadrature formula na to, should be able to give me the value or the exact value of the integral for any polynomial of degree 0 or degree 1. Kasi nga, ang degree precision niya ay 1, eksakto dapat yung pag-i-integrate niya ng degree 1 or degree 0 polynomials. Tapos, sabi ng linearity property, hindi mo na siya kailangang i-check para sa lahat ng polynomials of degree 0 and degree 1. It is sufficient to show that your formula will be able to give you the value of the integral of 1 and x exactly. So pag na-integrate or pag nabigay sa atin ng quadrature formula yung integral ni 1 at saka yung integral ni x exactly, then this will be inherited by all polynomials of degree 1 or less. So ngayon, ready na ako ngayon para ibigay or para i-derive yung dalawang equations. Kasi nga, meron tayong 2n unknowns, magkakaroon tayo ng 2n equations, so ibig sabihin meron tayong 2 by 2 system. 2 equations in 2 unknowns. Paano ko makukuha yung mga equations na yon? Dapat eksakto yung integral kay 1, dapat eksakto yung integral kay 0. Okay? So let's see. So, ang gagawin ko, ito yung gusto kong equation na matupad para sa f equals 1 at saka para kay f equals x. Alright? Para dun sa basis ng set of polynomials of degree 1 or less. Now, ang gagawin ko, papalitan ko si f ng 1 to get my first equation. And then I'm going to evaluate this. So integral of dx from 1 to from a to b, that's going to be b minus a, right? So magkakaroon ako ng b minus a dun sa isang side ng aking unang equation. Now, how do I get the other side of my equation? Well, plug in f of x equals 1 in the quadrature formula. So si f ay papalitan ko ng constant function 1. Constant function 1 yan. So the right-hand side of this equation will be w1 times 1. So that's going to be w1. So the first equation in our system is w1 must be equal to b minus a. w1 nanggaling dun sa substitution sa quadrature formula. Tapos yung b minus a nanggaling dun sa pag-i-integrate ng constant function 1. Okay? And then the second equation can be derived similarly. So paano siya ma-derive? Okay, papalitan ko naman ngayon si function f by x. Okay? Pag pinalitan ko siya ng x, i-integrate ko yan. Integral ni x from a to b ay x squared over 2 evaluated from a to b. So that's going to be b squared minus a squared all over 2. That should be the value of the integral. So siya yung gagawin ko dito sa equation ko, yung right-hand side ng aking second equation dun sa system. Now, how do I get the other side of the equation for the system? Well, here, I will replace f by the function x. Right? So si f ay papalitan ko ng function x, pero i-evaluate ko siya sa x1. So that means f of x1, when f is equal to x, will be x1. So that means this guy will be w sub 1 x sub 1. And now we get our system of equations. Meron kang w sub 1 equals b minus a, at saka w sub 1 x sub 1 equals 1/2 b squared minus a squared. Tapos ito yung isosolve mo ngayon na system. The solution, so it's easy kasi given na yung w sub 1 ay equal kay b minus a, so you're good. B minus a, b and a are given in the problem because they are the bounds of the integral, so no biggie about them. Tapos, substitution na lang. Etong value ni w sub 1, gamitin mo rito, so you'll have b minus a times x sub 1, divide both sides by b minus a, so ito ay magiging over b minus a, so ito ay magiging 1/2 b plus a lamang. So ibig sabihin, the x sub 1 will be the midpoint, a plus b over 2. Right? So yun yung abscissa. Ang abscissa natin ay a plus b over 2. Tapos ang w sub 1 natin, yung weight associated with that abscissa is b minus a. So that means our formula, our quadrature formula would be, again, you see w1 was just replaced by the w1 that we got. And then x sub 1 here was replaced by the w sub 1 we got from our system of equations. And so our quadrature formula, the one-point Gaussian or the quadrature rule, or the one-point Gauss-Legendre quadrature rule is b minus a times f of a plus b over 2. Does this look familiar? It should, because it is the midpoint rule. Nag-coincide ngayon na yung midpoint rule, siya rin pala yung one-point Gaussian quadrature rule. Okay? Is that okay? Medyo mabilis yung discussion, no? But I hope you followed. Kung digesting pa, okay lang yan. You can go back again and then do it by hand or redo the calculations. I hope that is fine. And that's the general course of action that we'll be doing. Ano? Kaya lang minsan medyo mahirap, lalo na pag malaki na yung degree of precision, marami ka ng points na ginagamit, palaki ng palaki yung system. Ano? I hope you can imagine how complex the system will become if you have a larger value for n. So usually, ang ginagawa natin, nag-change tayo ng variable para mas madaling i-handle yung pag-solve ng system. In particular, we are changing the variables so that the boundaries will not be an arbitrary A and B, but they will be -1 to 1. Kasi kapag yung interval mo ay -1 to 1, maraming right-hand side ang magze-zero lamang. At mas madaling mag-compute mag-solve ng system kapag mas marami sa kanila ang naka-equal kay 0. Okay? So in that respect, okay, so we will introduce the change in variable. So we'll make x, or we'll let x to be equal to b minus a over 2 times t plus a plus b over 2. So from integrating with respect to the variable x, I'll perform the integration with respect to the variable t. So substitution lang to. So ngayon, yung integral natin para kay f over the interval ab with respect to x ay mapapalitan, or papalitan ko ng integral with respect to the variable t. So you can retrace the steps here. This is just your basic substitution for integrals. So essentially, we'll get this guy. Ito ay integral from -1 to 1 ng b minus a over 2 times c plus a plus b over 2. Okay? So parang ano lang, mas pinadali natin yung derivation. So how will this factor in our quadrature rule? Papakita ko later, pero yung derivation makikita nyo mas madali. This might just look cumbersome, ano? Pero when you solve the system, you will find the abscissas, or you will find abscissas over the interval -1 to 1. Etong formula na to, yung magbibigay sa atin ng conversion pabalik dun sa interval AB. Okay? So, but probably you'll do that later kasi wala na pala akong time, ano? I'll just share with you the recording nung from last year para panoorin nyo over the weekend in preparation for the lab exercise. And then siguro the first hour of your lab session on Monday will be devoted to your lab for your lab instructors to answer your questions about the video that I will share with you. Ano? Para hindi na kayo magdi-discuss diretso, para may time kayo more on magawa ng laboratory exercise. But I'll share with you later today the video, the remainder of the discussion of this module, para well-equipped na kayo over the weekend to do the problem set, which I'll give probably tomorrow noon, ano, para i-clarify na lang ng mga lab instructors nyo on Monday kung ano man yung questions na meron kayo. Okay? So tingnan natin, allow me to borrow probably 5 more minutes. Okay. Para lang ipakita yung paggamit nitong formula na to sa pagde-derive or nung translation or yung change of variables sa pagde-derive ng Gaussian quadrature rule in 2 points. All right? So for this particular formula, we'll be using n equals 2. 2 points. So ibig sabihin meron tayong 4 na degrees of freedom. I need to solve for x1, x2, w1, and w2. All right? And then since we have n equals 2, the degree of precision will be 2n minus 1. So that's going to be 3. So yung formula na to, dapat kaya niyang i-integrate ng eksakto yung mga polynomials of degree 3 or less. Pero para ma-ensure na ma-integrate niya yung polynomials, all polynomials of degree 3 or less, dapat ma-integrate niya si x cubed, si x squared, si x at saka si 1 ng eksakto. So that's how we're gonna choose W1, W2, X1, and X2. Dapat ma-integrate natin eksakto si 1, si x squared, at saka si x cubed. Now, we translated our interval. Instead of the arbitrary a to b, we'll do the derivation over the interval -1 to 1. And you will see why did I choose to do so. All right? Kasi gagawin natin, naghahanap tayo ng formula na ganito yung itsura. Okay? So una kong gagawin, papalitan ko si f by the constant function 1 para dun sa unang equation. Now that will be the integral of 1 dx from -1 to 1. The answer is 2. So the right-hand side is 2. Tapos si f dito papalitan ko ng constant function 1. Constant function 1. So that means the left-hand side here will be w1 plus w2 equals 2. That's your first equation. The second equation will be obtained by replacing function little f by x. palitan mo siya ng x. So magiging integral siya ni x from -1 to 1. So magiging x squared over 2 evaluated from -1 to 1. Pero yon ay mag-equal lang sa 0. And that's why I love the interval -1 to 1. Kasi kapag ka-odd yung power ni x, laging 0 lang yung right-hand side ng equation. You see kung bakit ngayon gusto ko yung interval -1 to 1. That makes deriving the equations much easier. Because whenever x will have an odd exponent, the integral will just be equal to 0. Tapos kailangan nyo na lang palitan si f dito by x. So x evaluated at x1, that will give us x1. Yeah. And then f evaluated at x2, that will give us x2. And hence we'll have w1 x1 plus wx2 in our second equation. And then the same thing for x squared. Tapos kay x cubed naman, dahil si x cubed odd yung exponent, alam ko 0 na yung right-hand side nun, nung fourth equation natin. So ang gagawin ko na lang, papalitan ko yung f dito at saka yung f dito by x cubed. So w1 times x cubed evaluated at x1, that will give me w1 x cubed, plus w2 times x cubed evaluated at x2. So it's going to be x sub 2. Nawala yung sub 2 rito. Yeah. w2 times x2 times x sub 2 cubed equal to 0. So you have this 4x4 system. Okay. Now you can use an online solver. I think MATLAB can still solve this using its intrinsic built-in equation solver. So pag pinasolve nyo to sa isang solver or kung magaling kayo sa manual computations, you'll get w sub 1 and w sub 2 to be equal to 1. So ibig sabihin yung first term saka yung second term sa quadrature rule, parehong 1 yung weight nila. Tapos ang x1 ay -1 over root 3. And then x2 will be 1 over root 3. Okay. So ibig sabihin, ito yung abscissas mong gagamitin. Kaya lang, kung mapapansin nyo, itong abscissas na to ay numbers between -1 to 1. Because here we solve an integral over -1 to 1. But our integrals will not just be integrals from -1 to 1. Kaya kailangan nating i-translate yung formula na makukuha natin. Okay? But essentially, you can start by building up the formula for the integral from -1 to 1. So yung integral from -1 to 1 of f of x dx will be equal to w sub 1, which is 1, times f of x sub 1, plus w sub 1 times f of x2. So this would be the two-point Gaussian or Gaussian quadrature rule, or the two-point Gauss-Legendre formula. Okay? Now, sir, paano ang gagawin ko kapag ang interval ko na ay hindi -1 to 1? Well, gagamitin lang natin itong conversion formula na to. Let me just copy this over dito. Okay. Para ma-translate ko itong formula na to na nagwo-work lamang para sa mga integral from -1 to 1, okay? Pabalik para sa integral on the interval AB. All right? So note that if we will convert this to integral from a to b of f of x dx, sabi nung derivation natin dito sa change of variable natin, ito daw ay equals sa b minus a over 2. Ito yung formula na kinopy-paste ko kanina, times the integral from -1 to 1 ng f of b minus a. Actually, hindi ko na siya kokopyahin. Ito siya. Yung integral from a to b of f of x dx ay equal daw dito. Right? So, kokopyahin ko yung b minus a over 2. Tapos, imumultiply ko daw siya sa integral nito. Alright? Pero itong integral na to ay integral from -1 to 1. So, pwede kong i-apply itong quadrature formula na to sa pag-evaluate nitong formula na yan. Or pag-evaluate nitong integral na to. So essentially, what I'll have is times f of si t rito ay mapapalitan kung ano yung x sub 1 na napili natin over the interval -1 to 1. So ibig sabihin, the first term will not just be f of negative 1 over cube root of 3, pero siya ay magiging b minus a over 2 times negative cube root of 1 over 3. Sorry, cube root, why cube root? Square root of 1 over 3. So this would be 1/2 of b minus a over 2 times negative root of 1/3 plus a plus b over 2 plus f of b minus a over 2 root of 1 over 3 plus a plus b over 2. So essentially, ang nangyari rito ay yung exabytes na na-compute natin mula dun sa ating system of equations, siya yung ipapalit ko rito sa t na to. Right? And that's why in the example, you see that ito yung itsura ng implementation ng Gauss Legendre formula of 2 points sa pagko-compute ng ln2. Kasi nga, dito ko gagamitin yung Gauss Legendre formula. Right? So ang function ko ay may argument na b minus a over 2 times t plus a plus b over 2. So itong exabytes na to, ipa-plug in ko lang dun sa t so that I'll get the two terms in my Gauss Legendre formula. Okay? So to familiarize yourselves here, I suggest you try examples 9.2 and 9.3. And then I have here a couple more pages, but para maiksi na lang naman to, so I'll share with you a recording of my discussion of example 9.2, and I hope that will give much more light dun sa mga minadali kong i-discuss ngayon, specifically yung translation. But if you still have some questions habang nagagawa kayo ng laboratory exercise, feel free to message me over the weekend kung merong hindi clear or you're not sure how to implement the translation formula, or you can wait until Monday para itanong siya sa mga lab instructors niyo during the first few hours of your laboratory class. Okay? But I need to stop here. Do you guys have any burning questions? Okay, so if there are none, then thank you guys for joining me today. Enjoy the weekend. Tapos kita-kita ulit tayo on Wednesday. All right? Bye, guys.